In today's class, we are going to learn the graphical verification of equations of motion. There are three equations of motion. The first one being V is equals to U plus AT. The second one, S is equals to UT plus half AT square. And the third equation, V square is equals to U square plus 2AS. So we'll be proving all these three equations using graph. We'll also be using a formula. Take a note that when acceleration is constant, average velocity is equals to U plus V by 2. Okay, so we're going to make the graph. I'm using a pen, but you use pencil. I'm using pen so that you can see this clearly. Say the body starts from a certain initial velocity and reaches to a final velocity V. Starts from U and reaches V. Say the time taken be t. So this is time. This is our velocity. We are using a velocity time graph. This is our origin denoted by O. We'll be using these points, so let's name them. O, say this point we name as A, B, C, D, and say E. So acceleration A is equals to slope of line EC, because acceleration in velocity time graph is given by the slope of the line. This is the line representing the velocity, so slope of line EC will give us the acceleration. Now how do we find the slope? Is we take what is there in the y axis, this length BC divided by the length in the x axis. So in the y axis we have length as BC by in the x axis we have length as BE. Slope is basically we can say is change in the y axis by change in the x axis. So BC, as we can see, we can write as DE, and BE is equals to OA. BC is equals to DE, as this is a rectangle, and BE is equals to OA, as OABE is a rectangle. Opposite sides should be equal. Now DE, this DE will be equals to V minus U. This portion, this whole is V, the small portion is U. So this portion will be V minus U. And OA is basically equals to T. So from here we have A is equals to V minus U by T. T comes over here. AT is equals to V minus U, which implies minus U comes over this side. U plus AT is equals to V, which implies V is equals to U plus AT. So this is our formula for first equation of motion. We'll just mark this one and give it number 1. For the second equation of motion, we'll find the area between this graph, because area between the graph gives us displacement, and what we need to find is the displacement. So displacement S is equals to area of this figure over here is a trapezium with two sides, one pair of sides, opposite sides parallel, and one pair of sides is non-parallel. So area of trapezium OACE. And we know that to find the area of trapezium, what we do is we take the sum of parallel sides. This and this side is parallel. So OE plus AC by 2 into the distance between them. The distance between them, this perpendicular distance, is OA. So OE is basically U. AC is basically V by 2 into OA is basically time T. Now from equation 1 we know that V is equals to U plus AT. So U plus, instead of V you will write U plus AT by 2 into T. So from here we have U plus U is 2U plus AT by 2 into T. So if we take 2 separately, 2U by 2 is U plus AT by 2 into T. So this implies S is equals to UT plus AT square, and we have division by 2, so half AT square. So this is our second equation of motion. So now we'll do the third equation of motion. For the third equation of motion as well, what we are going to use is the same formula that we used for our displacement. But before that, we are going to use average velocity is U plus V by 2, which implies average velocity is basically displacement by time is equals to U plus V by 2. Which implies S, 2 comes over here, 2S is equals to U plus V into T, and from, let's mark this equation as star. A is equals to V minus U by T. We mark this equation by star. Let's say this is star. A is equals to V minus U by T. From this equation star, what we can write is A is equals to V minus U by T. So from here, if T goes to the other side, T is equals to V minus U by A. We'll mark this equation as, say, number 3. Let's say this is number 4, and let's say this is number 3. So from 3 and 4, 2S is equals to U plus V into, instead of T we'll write V minus U by A. This implies A is in the denominator, comes this side, multiplication. 2AS is equals to V plus U into V minus U, becomes v square minus u square. A plus b into a minus b is a square minus b square. So this implies u square comes this side, so v square is equals to u square plus 2as. So this is our third equation of motion. So these are our three equations of motions. First one, we took the slope a as slope of the line AC. We found the slope and we derived the first equation of motion. For the second equation of motion, we took displacement of this graph EC. So it will be equal to the area of trapezium OACE, because displacement is given by the area under the graph of velocity time. So after finding this area, we derive the equation of displacement, the second equation of motion, and we also replaced in between v as u plus at. For the third equation of motion, what we did is we started with average velocity is u plus v by 2. From here we got 2s is equals to u plus v into t. And from the formula for acceleration, a is equals to v minus u by t, we get t is equals to v minus u by a. So solving this two, we replace t in this equation. We get 2s is equals to u plus v, which was already there, and instead of t we replace v minus u by a. So a being in the denominator changes side, becomes multiplication. So 2as is equals to v minus v square minus u square, because a plus b into a minus b is a square minus b square. U square changes side, so v square is equals to u square plus 2as. So v square is equals to u square plus 2as. This is our three equations of motions. Now we will solve some problems relating the same. So the first question that we are going to deal with here is a ball is initially moving with a velocity of 0.5 meter per second. Its velocity decreases at a rate of 0.05 meter per second square. Okay, so whenever we are given question, as we read the question, we need to write whatever information is available to us. So a ball is initially moving means initial velocity u is equals to 0.5 meter per second. Its velocity decreases at a rate of this much, means this is the retardation. So acceleration, whenever velocity decreases, we say acceleration is negative or there is retardation. So acceleration will be minus 0.05 meter per second square. How much time will it take to stop? So from this we can conclude that the final velocity v is equals to 0. So for part A, so we have u, we have a, we have v. What we need to find is the time. So we have v, we have u, we have a. What we need to find is the time. So we'll use the first equation of motion. So we know v is equals to u plus at, which implies 0 is equals to 0.5 plus minus 0.05 into t. This one, a negative comes this side, becomes positive. 0.05 into t is equals to 0.5, which implies t is equals to 0.5 by 0.05. This decimal goes, we get a division by 10, and when this decimal goes, division by 100. And denominator's denominator comes to the numerator, so multiplication by 100. Now 5 and 5 cancels off. 1 0 cancels off. So this implies time is equals to 10 seconds. Number B. How much distance will the ball travel before it stops? We have u, a, v, t. We need to find s. So we have u, we have t, we have a, we have t as well. So we can use the second equation. We have u, we have v, we have u, we have A, we can use the third equation as well. It's our choice here. Say we use the second equation of motion. S is equals to ut plus half at square. So S we need to find. U is our 0.5, time is 10 plus half. A is minus 0.05 into time is 10 into 10 t square. So 0.5 into 10 is 5, plus into minus becomes minus. 0.05 into 100 will become 5 by 2. On subtraction, we are left with 5 2s are 10, 10 minus 5, 5 by 2, which is equals to 2.5 meters. So this much distance the ball will travel before it stops. Now the next question. A car initially at rest starts moving with a constant acceleration of 0.5 meter per second square and travels a distance of 25 meters. Find its initial velocity and the time taken. So car initially at rest. From this we get initial velocity u is 0. It's moving with a constant acceleration of this much. So we have the value of acceleration as well. Acceleration A is 0.5 meter per second square and travels a distance of 25 meters. So displacement S is equals to 25 meters. Find its initial velocity. We have UAS. So which equation of motion we are going to use is the third equation, because we have V, we have U, we have S, we need to find so we have A, we need to find the we have U, the initial velocity, we have A, we have S, we need to find V. So we'll use the third equation of motion. So first part, we know V square is equals to U square plus 2AS. So this is equals to U square is 0 square plus 2 into A is 0.5 into S is 25. So this is equals to 25 into 2 is 50. So 50 into 0.5. If we remove the decimal, we get 5 by 10. 0 0 cancels off. So V square is equals to 25, which implies V will be equals to root under of 25, that is 5 meter per second. For the second part, we need to find the time taken. So we have V, we have U, we have A. We'll use the first equation of motion. V is equals to U plus AT. This implies 5 is equals to U is 0 plus A is 0.5 into time is T. So from here we get 5 by 0.5 is equals to T. Decimal goes off. We have multiplication by 10 in the numerator. 5 and 5 cancels off. So we have time as 10 seconds again. So now the next question. Solution. A particle initially at rest moves with an acceleration of 5 meter per second square for 5 seconds. Find the distance traveled in 4 seconds, B 5 seconds, and C the 5th second. Okay. So again we'll begin with what is given to us. Initially at rest, so initial velocity is 0. Acceleration A is 5 meter per second square. Time T is 5 seconds. Find the distance traveled in 4 seconds. So we'll use the second equation of motion to find the displacement. So We know, we'll mention this as S1 because we need to find two different distances. We'll mention them as S1 and S2. So S1 is equals to, time is 5 seconds. So the first case we'll use S1 is equals to U into T1, where we'll write T1 is 4 seconds and T2 is 5 seconds. UT1 plus half, acceleration is constant, into T1 square half AT square. So which is equals to U is 0 into 4 plus half into 5 into T1 is 4 square. So 0 into anything is 0 plus half into 5 into 4 square 16. 2 8s are 8 5s are 40 meters. For number B, we know same process again. S2 is equals to U into T2 plus half A T2 square. This will be equals to 0 into 5 plus half into acceleration is also 5 meter per second square into time is 5 square. So 0 into 5 0 plus half into 5 into 5 square is 25. So we have 125 by 2, which is equals to 62.5 meters. For C, the distance traveled in fifth second. So for the distance traveled in fifth second, what we'll do is S2 minus S1. Why so is because if you see the total distance traveled in 5 seconds and you take the time traveled in 4 seconds, if you have to find only for the fifth second, so from the distance traveled in 5 seconds, we remove the first 4 seconds, the distance traveled in the first 4 seconds. So the distance that is left will be the distance for the fifth second. So S2 minus S1 will get us 62.5 minus 40, that is 22.5 meters. So in the fifth second, he travels a distance of 22.5 meters. With this, we come to the end of the chapter. Please attempt all the questions in the exercises as well as all the e-text questions as well.